ahead today. So in the previous lecture, we have discussed about some properties of differentiation, along with, of course, the standard application of differentiation formulae. Okay, for differentiation of algebraic functions, the formula for differentiation of x to the power n. Okay, and then we have gone on to also discuss differentiation of the basic trigonometric functions. Okay, sine, cos, tan, etc. And we have also discussed about exponential function and logarithmic function. Okay. And of course, differentiation of exponential and logarithmic function. So let's begin with some basic recap of all these things, though I'm sure you must have done all this for the test also. Yeah, Vipul, you can unmute yourself if you need to speak. Okay.
Sir.
Yes.
Sir, you told that we won't have any sums on the division property or multiplication property.
Yeah. So there were no sums on that.
Yeah, there was one sum on that.
Tell me the question. I'll tell you there's a different way of solving it. You don't have to use division or multiplication.
Okay, sir.
Just tell me the question. Just send it to me. I'll explain it to you today. Okay, let's begin with an example set of questions. You want to find dy by dx for the following. Okay, just try out these 4 questions and send me the answers. Okay, then we'll continue ahead. These are based on all the basic formula and properties of differentiation that we've learned so far. And we haven't learned multiplication or division property yet, quotient or product rule. So don't worry, you don't have to use any of those in these type of questions. So I'm just listing out for your reference the formula that we've learned so far. Differentiation of x to the power n is given by this. This is the most basic and important formula of all of this. Okay. Then differentiation of trigonometric functions.
Sir.
Yes.
Sir, e raised to x when differentiated gives e raised to x only, no?
Sorry, come again, beta. Which thing differentiated?
Sir, e raised to x.
E raised by x is differentiation is e raised by x only. That's correct.
So, sir, in question number 17 in the physics paper, the question was different e raised to the power 100. So the answer should be e raised to the power 100 only, no?
Why? Differentiation of e raised power x is e raised power x, no? Because e raised power x is a function of x.
Yes, sir.
But what about e raised power 100? Is e raised power 100 a function of x?
It's a constant.
It's a constant value ना बेटा, इसका x से कोई dependency नहीं है. You understanding the point ना?
Yes, sir.
So it's a trick question actually, है ना? So differentiation of not just e raised power 100, but e raised power any number with respect to x, where n is a constant, it's a fixed number, is how much? Is 0, because you know differentiation of a constant is 0. You understanding now?
Yes, sir.
This was just a trick question. You will always have 1 or 2 questions which are like this. They are actually very simple, but it's just meant to trick you. Okay, that is one of the standard things in, you know, the competitive type of exams or JEE type of exams, right? So don't worry, in this exam you got tricked, but next time onwards be alert about these kind of things, you know? Okay, beta, which was the question you were asking about earlier? Can you send it to me just on? Very good. Arunima and Avi. Both of you got the first one correct. Very good.
Sir, the question was y is equal to x square upon x plus 1.
X square upon x plus 1. ये कौन सा question था बेटा बताओ?
Sir, question number 16.
Okay, let me just check. Okay. This question is not supposed to be in the test then.
Sir,
Anyway,
even one more question is there. Y is equal to root of tan root x.
Yes.
Okay, let me just check. You know, these questions have probably, okay, I'll have to get them cancelled from the test. Okay, this was okay. Just
sir,
yeah.
In the previous doubt lecture that was means taken by Ajit sir, he had just taught us how to use this division formula, but not in a depth. Like he had just
नहीं, it's fine. Division formula आपको मैं भी सिखाऊंगा है ना, but वो सिखाने के बाद ऐसे questions आएंगे ना. Don't worry, I will cancel these 2 questions from the test. They were not supposed to come in the test. There must have been some mix-up by the person who uploaded the test, because I had sent the questions myself and there were no questions which are based on division, and like that tan root x is something called chain rule. Okay, that is something that we'll be learning subsequently. Okay, so I'll get these 2 questions cancelled.
Taught us about chain rule, but not in such a depth that we could answer it.
So don't worry, beta. I will get these 2 questions cancelled from the test because they're out of syllabus for this particular test. Okay.
Okay, sir.
Okay. We'll do a discussion of the test questions also. Don't worry. Okay. Okay. Now tell me the answers for these questions, all of you. Like 2 people have already given me the correct answer for the first one. Okay, Avi, very good. Second one is also correct. Okay, so I'm verifying the first 2 questions. Those who have finished the first 2 questions, you just continue working. Okay. So y is equal to x square plus 1 upon x. So we can also differentiate by quotient rule, but we won't be using that here. I will just simplify this. I'll write this as this. So that's x plus 1 by x. Okay. So y is equal to x plus 1 by x. This implies this. Therefore, now it implies that differentiation of y with respect to x is differentiation of x plus 1 by x. So that's differentiation of x plus differentiation of 1 by x, which becomes 1 minus 1 by x squared. Okay. I've tried to make all the steps and not skip anything over here. Still, if some step is not clear to anyone, please let me know. I will explain in detail. Okay. So your final answer should be this for dy by dx. Now, similarly, is the second question. You first actually have to expand this x square plus 2x ka whole square. We have to expand this, and that becomes x to the power 4, right? Plus 4x cube, okay, plus 4x square. Now you can see that differentiation will become, okay. So once you practice, you can do this directly also, but right now I'm just showing you all the steps of the differentiation. And we can do one final step where we factorize this. Okay, so we can write this as this also.
Sir, can you just show how to do it with chain rule? Just for my reference.
Yeah, chain rule I'll explain better today. Now, just give me a bit of time. I will like do all the step, like do the full from basics. I'll explain chain rule in few minutes. Then I'll explain this question by chain rule. Okay.
Okay.
What you have to do in chain rule? You have to. Sorry, come again, beta.
So there you wrote y is equal to x to the power 4 plus x cube. So
4x cube.
2x square, right? So
No, beta. See, I'm using this formula, na, a plus b whole square. You understanding, na? ये होता है ना? Now यहाँ पे got it? Is it clear, beta?
yes, sir. Yes, sir.
Okay. So one has to be a little careful with the steps, right? Yeah. Now coming back to your reference about chain rule, na, I will explain chain rule in detail. But here, if you want to apply chain rule, na, what you'll have to do is you'll have to put x square plus 2x as some new variable z. So y will become z square. So then differentiation of y will become 2z because it's z square into dz by dx. So 2z will be nothing but 2 into x square plus 2x into dz by dx is differentiation of this. So that will further become 2x plus 2. And then you'll have to open this bracket and express it this way. Okay.
Okay, sir.
So you'll get the same answer.
We'll
when you factorize it or like this, you'll get the same. So if you have done chain rule before, if you learned it before, then you can apply this method. Otherwise, don't worry, I'll be explaining it step by step. I haven't done chain rule over here at all as yet. So, I'll explain everything from the basics about chain rule. In this question, it's not compulsory to use chain rule. As you can see, it's quite simple to actually expand it this way and differentiate. Okay. Yeah. Somebody else had a question?
Sir, so in this chain rule, we first solve the first function and then the another function.
Yeah, I'll explain bit in detail. I'll explain. Don't worry, Harsha. But as I said, in a question like this, now we don't need to use chain rule. In fact, it's unnecessarily going to complicate the question. We should first try to algebraically resolve the question as much as possible before we get into something like chain rule. So here, by expanding the whole square term, we can easily resolve it. So there's no need to use chain rule. Okay. Now, similarly, for the third one, ln of x cube, you will use the property of ln.
Sir, I have a doubt.
So these are the formulas so far, and of course the basic properties, sum and difference of functions, constant multiplied by function, those kind of things.
So can you explain the third one again?
Yeah, Tanay, which one? Explain second last and last step of question 1.
Yes.
Okay, just a minute. Second last, you mean this step? Here to here?
No, sir. The other
This one?
Yes.
Other one? Okay, so differentiation of x to the power 1 kya hoga? 1 hoga? Just apply this formula. X to the power 1 hai na? So it will be 1 into x to the power 0, which is 1, correct?
Yes.
Or differentiation of 1 by x kaise karenge? We'll write it as differentiation of x to the power minus 1, na? And then we'll use this formula, this one. So minus 1 into x to the power minus 2. So that's how much? Minus 1 by x square.
Okay. Got it.
So
Yes.
can you tell like how did you got 1 by x after ln x?
Differentiation of
So
ln x
that-
1 by x kyun aaya? Okay. See,
Yes.
that is a formula that has to be derived by a limits method, which we have not discussed in calculus yet. Okay. We'll discuss about that in a more advanced course in calculus. Here you have to just take it as a formula. Okay. This is one of the formula of differentiation. One of the fundamental formula.
Okay.
Just like
Okay,
differentiation of e raised power x is e raised power x. इसको भी मैंने prove नहीं किया है ना? मैंने अभी तक बहुत कम formula prove किया है. I've just proved that differentiation of x square is equal to 2x. Then I've proved that
Yes.
differentiation of x cube is 3x square. Other than this, I have not given you the proof of any of these. Okay, these are all basically just fundamental formula that we give. But at some stage now, we will learn that there is a basic proof for all of this. But remember, for physics, for us, the proof is not important. The application is the more important thing, right?
Okay, sir. Okay.
So just remember these fundamental set of formulae. Okay, very good. Couple of people have got the answer to the third part also correct. It will be 3 by x Vedant. That's correct. Very good. Okay. So how we will get this ln of x cube ka differentiation? Okay, let's discuss. So I'm just going to pick up these couple of questions here. Now I'll use a property of log that log of a to the power n is n log a. Okay, so therefore, ln, which is natural log of x cube, is nothing but 3 times ln x. This is the property of logarithm. Another important property of logarithm is that log of AB can be expanded as log A plus log B, or log of A divided by B can be expanded as
log A minus log B.
Yeah, log A minus log B. Okay. And this could be to any base. So here it is to the particular base exponential or ln. Okay. So this is the first step we'll do here. So we will write y as 3 times ln x, and then the differentiation becomes very simple. So again, like those of you who are talking about chain rule earlier, this is a question we can do by chain rule also, but it's not compulsory to do by chain rule. In fact, it's easier to first simplify y as 3 ln x and then apply the direct application. The differentiation of ln x is 1 by x. Okay. So our final answer dy by dx should be equal to 3 by x. So there are a lot of things that we can do even with the simple properties that we have learned till now and the simple formula that we have learned. Okay, even though we are not applying anything very tricky or fancy over here. Like you can see, this question just looks very lengthy and scary, but actually we don't need to do anything extra. We don't need to apply quotient rule or anything we haven't learned so far. It's just based on the simple principles that we've learned so far. Okay, but we just have to first simplify the expression before we can differentiate. So y equal to, yeah.
Sir, in this, couldn't we write it as ln of x cube as 1 by x cube?
No, beta. Differentiation of ln x cube will not be 1 by x cube. No? The formula is differentiation of ln x is 1 by x. But that doesn't mean that the differentiation of x cube is 1 by x cube. You're getting my point now?
Yes, sir.
Okay, so that's why. Okay, so this we can now simplify as sin x by cos x.
So tan x minus plus 2 cos x.
Correct. So, this can further be simplified as y is equal to tan x minus 2 cos x. Okay. Sorry, plus 2 cos x. And then we can just apply the standard formula of differentiation which we had written above, that tan's differentiation is sec square and cos's differentiation is minus sine. Right. So as I told you, with practice, you can skip some of these steps and write the answer directly. But initially, when you are doing differentiation for the first time, like we are doing right now, we should try and write all the steps as systematically as possible. Okay, so that we don't make any mistake. So I'm writing all the steps systematically one after the other. So this should become my answer. Right, so just quickly go through these two questions solution also. You don't need to write down every step right now. I will send you the notes. Okay, just make sure you understand the steps. If there's any doubt, please let me know.
Sir, could you please show those formulas related to this?
Formula? Yeah, yeah, okay. Just go through this once. I'll take you back to the formula above. Okay.
Okay, sir.
Okay, so hope these steps are all clear. Just going through messages again. Yeah, seems that everybody is clear with this. Okay, I'll just quickly take you through those formulae once more. Then we'll move ahead. Okay. So these are the basic 9 formulae you can see. 6 of them are trigonometric, then exponential, logarithmic, and the basic, the most commonly used one, which is for differentiation of x to the power n. Okay. So I hope in this level of question by now all of you are confident, right? Like if a couple of questions have come outside of this method, like the questions you pointed out, it's unfortunately come by mistake. I had sent a question set which was specifically for this level only. Maybe there has been some mistake in uploading for the test, so I will just verify that once. Okay. Don't worry about the 2 questions which have come, which cannot, which you pointed out. I will just remove them from the test analysis, so it will not affect your marks. Any case, this test is for practice, so don't worry about that so much. Okay. But the
there will be no.
Sorry.
So there will be no selections like on the basis of this test, like before the previous one, KVPY.
Selection for what, beta?
Like so for major test.
No, this major test is for practice, beta. Okay, we are not doing any segregation of batches and all that from this major test. Okay, don't worry about that.
Okay.
Okay. This is just for you to get used to the JEE pattern, and also like it's giving you another practice of what we have done till now. So the questions you can test yourself whether you are able to solve the question in examination condition. No, you already tested that you can do it in the homework assignment, right? So immediately, Abhi, don't take too much pressure about marks and all that. Just make sure that after doing the test, if any questions you could not attempt, which were within syllabus, okay, which is most of the questions anyway, you understand where you made a mistake or whatever you couldn't understand, just make sure you do that. Okay. Okay, now let's move ahead in differentiation. So we will now see the next 2 properties of differentiation. Okay, so coming back to properties of differentiation. Yes, Vatsal, on an average, you will be having a test almost every week very soon, because we'll also be having subject-wise tests. This was a major test, so all 3 subjects in JEE Mains pattern. But in future, you will also be having like what we call DPTs or chapter-wise tests. So it will be like 1 chapter of 1 subject at a time, like a single vectors test or a single calculus test. So those will be starting very soon when we finish a little bit more of the syllabus. Okay. So those also will be like practice tests, and then the major tests will become like, you know, the more serious type of tests, which are for your testing yourself at the JEE level. Okay. And from third test onwards, the major test will have two papers. One will be the JEE Mains pattern, and the other will be the JEE Advanced pattern. The first couple of tests, it will only be Mains pattern, like we've taken last time. Okay. For major test 1. Okay. Now coming back to properties of differentiation. So we've already seen 3 basic properties. That differentiation of a constant is 0. We've used all this in the above questions also. Okay. Then differentiation of a constant multiplied by a function is equal to the constant multiplied by differentiation of the function. Okay. And we've seen that differentiation of the sum or difference of two functions is equal to like the distributive property. Differentiation of first function plus differentiation of the second function. Okay. Or if there's a minus sign in between these two, so it's minus differentiation of the second function. So these are the first 3 basic properties. Okay. Now just to write properties like this in a more simple manner, we also use a short form. We use a shorthand notation wherein the differentiation of a function is given with a short form f prime x. Okay. So like this. Okay. So for example, this we can write it in this manner, that differentiation of f1 plus f2 is simply prime of f1 plus prime of f2. So this prime itself means it is differentiation. Okay. So differentiation of fx, which gives us the rate of change, the instantaneous rate of change, is also given by this short form. And this short form is sometimes also called the derivative of fx. So for example, if I ask you that what is the derivative of, let's say, sin x, so you know the answer to that it is cos x, because the differentiation of sin x is cos x. So basically what this means is that if I'm taking a function as sin x, then the differentiation of the function, which I can write in short form as f prime of x, is nothing but differentiation of sin x or cos x. So this is the derivative of this function. Right? So fx's derivative f prime is in this case cos x, because fx is sin x. So this is nothing new or nothing different. It's just a matter of a different name and a different shorthand notation. Instead of writing this whole thing d by dx of fx in short form, we just write it as f prime x. So it means the derivative or rate of change of that function. Okay. So this is a point. Yeah.
So it's a derivative and differentiation is the same thing. Right?
Yes, yes. Derivative is another name for, you can say like this, that differentiation is the process, okay, that we apply to the function. But what we get by applying the process, that is called the derivative.
Okay, sir.
And like addition is a process, but what you get is called the sum, right? Like that. So differentiation is the process we apply. What we get by applying differentiation is called the derivative.
Okay, sir.
Okay, now we come to the next property of differentiation. This is something new for us today. Okay, this is called the product rule. So this is another property of differentiation, that if y is a function which is the product of two functions. Okay, for example, if y is equal to x square into e raised power x, so it is the product of two functions. Now, fx is x square, gx is e raised power x, so y is fx into gx, that kind of thing. Then for applying differentiation, we use this property. It is first function into differentiation of second function plus differentiation of first function into second function. And since there's a plus sign in between, we can write in any order. So we can write this as G into F prime plus F into G prime also, or like this. Okay. So is this where F prime X is nothing but differentiation of Fx, as you know, and G prime X is nothing but differentiation of Gx, as you know. Okay. So simple way to understand this is with a direct example. So we have the example of y is equal to x square into e raised power x. So differentiation of y with respect to x. This will become what? The first function for me is x square. So I'll let x square be and multiply it with differentiation of the second function, which is this, plus differentiation of the first function, which is differentiation of x square, multiplied with the second function, which is e raised power x. So this will become x square into e raised power x, okay, plus 2x into e raised power x. So you can see that this is finally becoming x square plus 2x into e raised power x. So this is this. Okay. So just note down this formula, okay, which is basically another property of differentiation, and then make sure you understand how we have applied it over here to this particular question.
So
Yes.
So here there are only two variables like x square and ex. If there was a like third variable, something like.
So then we would have to apply product like in that sense, like take two at a time. So if y is, but that will become like unnecessarily lengthy question at this stage. So if I have three functions f, g, and h, okay, so dy by dx, I'll write as f into derivative of gh plus, okay, and then when I take this inside, this will become g prime h plus gh prime. Okay, so it will become like this. This kind of thing, where f is basically some function of x, g is another function of x, h is also another function of x.
Okay, sir.
But at our level in physics right now, we'll rarely see something where we need to apply something so lengthy. But typically just this type of product law, simple product law for two functions, that will be enough.
Okay, sir.
Of course, in your advanced calculus syllabus in maths, which will happen in class 12, you will get more complicated applications where something like this can happen. Okay, so if all the steps in this particular question are clear, let's look at an example. So y is equal to, let's say, root x into sine x. So find dy by dx for this. Okay, very good. Vedant and Avi. Okay, so again, like it's just a matter of getting used to how to apply the property, and of course the fundamental formula of differentiation we have to remember. So we will treat this as our f and this as our g. Okay, so dy by dx we can write in whatever order we like. We can write it as f prime g plus fg prime, or we can write it as fg prime plus f prime g, or whatever order we like, but that's the important thing. So dy by dx, I'm going with this now. So it is differentiation of root x, okay, multiplied with sin x plus root x multiplied with differentiation of sin x. So differentiation of root x, you know, is 1 by 2 root x, and differentiation of sin x, you know, is cos x. So you can write it as or we can take LCM also now, and we can write it as sin x plus 2x cos x, whole thing divided by 2 root x. So at this stage, this and this are equally right. But for MCQ questions also, you must learn how to simplify one form into another. Okay, because the answer might be given like this. Okay, so you must know how to convert this one into this. Arunima, correct. You got that one also. Yeah, Vedant and Tejas, correct for the second one. Arushi, correct. Okay, so here we will take the differentiation as, again, differentiation of first function x square.
Sir, there is a scam. Sir, please remove him from the meeting.
Okay, so let's get back to this. So differentiation of x square into the second function ln x, okay, plus x square multiplied with,
Sir, I had a doubt in previous question.
yeah, which one did you tell me?
Sir, in the second step, in the first step after we split it, sir, how it is half and 2 is multiplied by root x.
I'll explain.
Okay, sir, sorry, sir, I understood.
This one,
now.
this step?
Sir, I understood.
Understood. Okay. Okay, so hope these questions are clear to all of you.
Yes, sir.
Okay, so that is about the product rule. It's very simple. Now you can see one thing interesting. We can use the product rule to generate the algebraic functions of differentiation. Okay, so for example, you know that logically the differentiation of x should be 1 because you know that y equal to x kya hai basically it's a straight line jiska slope unity hai. Okay, so this has a slope equal to 1. So obviously this is okay. But now if you use product rule, so differentiation of x square, you can also prove that it is 2x by using product rule. Okay, you can treat it as differentiation of x into x. So that is differentiation of x whole thing into x, okay, plus x. I mean, it's really an unnecessary way of doing things, but you can see it gives you an interesting result. So it is 2x. So once you got this, that okay, differentiation of x square is equal to 2x. Now next thing you can see that okay, that what should be differentiation of x cube. So you just continue this series. You write this as x square into x. Okay, so that will become differentiation of x square into x plus x square into differentiation of x. Okay, so next step you can see this will become 2x into x plus x square into 1. So as you can see, that's becoming 3x square, which you know by formulas. Okay, so that's an interesting result that you get from repeated application of product rule also. Okay, so this example and this example. Okay, anyhow, we don't really use product rule for this. We use product rules when we have a situation where we have basically different types of functions. Like we had, that function of x or square root of x into sine x. Now we can't simplify this. If we have a function of x into x square plus 1, for this we should not use product rule. It will unnecessarily make it lengthy. We should actually first simplify this as x cube plus x and then directly differentiate. Okay, but if we have a function like this, you cannot simplify it into something which you can directly differentiate. So here we have to use product rule. So for those kind of things, we use the product rule method. Yeah.
So can you explain this example which you have written over here, d by dx of x cube?
X cube को मैंने split कर दिया ना. I wrote it as x square into x.
Okay, show
Yes,
that
sir,
sum again, please.
Yeah, it's actually just an example that is showing you the formula why differentiation of x cube comes out to be 3x square using the product rule. X cube I've written as the product of x square into x. Okay, so that is differentiation of first thing into second plus first into differentiation of second. Now above I just proved that differentiation of x square is 2x. So I'll replace differentiation of x square as 2x into x plus
But why
x.
did we square that? Means in the example, the question is given that dx by delta x. In the bracket on, why did we square that?
कहाँ square किया बेटा?
जो मतलब जो second example में दिया है ना जो first line में, second example की first line में.
So this is what I'm finding out. I have not proved this. This is differentiation of x square. I'm writing that now as differentiation of x into x. No?
Okay.
Understood? No? Differentiation of x square. I'm writing as I'm splitting x square as x into x. So and that's how by using the product rule I'm showing that differentiation of x square.
Okay. Means it was already given in the question. Okay.
So now similarly differentiation of x cube I can split as x square into x and use the same method. Like that I could go further up the series. I could prove differentiation of x to the power 4 as splitting it as either x cube into x or x square into x square. And like that I could come up with the general formula of differentiation of x to the power n.
So I'm not going to understand the second step, sir.
Which second step, beta? In which one?
That d by dx of x square into x.
So ये product rule है ना बेटा. Differentiation of one function into another is differentiation of first function into second plus second function into differentiation of first. Understood?
Okay, and after that, sir, what have you done?
After that,
you have done that 2x that the formula.
Differentiation of x square is 2x. We just proved that above, right?
Yes, sir.
And differentiation of x is 1. We just saw that above here.
Yes, sir.
Right? So just by using the repeated application of the product rule, you can show why differentiation of x to the power n will become nx to the power n minus 1.
Yes, sir. Thank you, sir.
Okay, now this is clear now?
Yes, sir. Yeah.
Okay, very good. Okay, now next is what we call the quotient rule. This is the final property of differentiation. There's also something called chain rule, but we can't really call that a property of differentiation. That is altogether different method that is used in differentiation. So the quotient rule is for something like this. If we have a function, if we have y, which is the quotient of two functions. Okay. For example, we have y is equal to, let's say, sin x divided by x square. So then we have to use this quotient rule method to differentiate. So dy by dx. Now this one is a bit of a complicated formula. It is given by denominator multiplied by differentiation of numerator minus numerator multiplied by
सुनो कुछ मत हो जाओ इतने सुनो नहीं कैरियर नहीं है कैरियर जरा भी नहीं है
Sir, I think this is someone like is being fraud.
Sir, I think someone has circulated the link to anyone else, so that is why.
Sir, you can lock the meeting so no one can enter.
Yes, sir.
Yeah, just a minute.
Sir, that voice
I'm just going through the, like, all of you please put your roll numbers in the
के अंदर ना 4-5 ऐसी फोड़ी आ गई है
Okay, so it's very unfortunate that somebody has circulated the link, but anyway, we'll get to the bottom of this. Okay. Right. So let's come back to quotient rule. Let's go over this again. So if a function or if y is given as the division of two functions or quotient of two functions, like sin x upon x square, then dy by dx is given by this formula that it is the denominator function multiplied by differential of numerator minus numerator function multiplied by differential of denominator divided by the denominator function whole squared. Okay, so even this is a very lengthy sort of way of writing the formula. So in shortcut, we can write it like this, that y is equal to some numerator divided by denominator, where we understand that numerator is also a function, denominator is also a function. But they're different functions, obviously. Okay, so dy by dx is denominator into differential of numerator minus numerator into differential of denominator divided by denominator square. So for example, this function that we have y is equal to sin x upon x square, dy by dx will become by this formula denominator, which is x square, into differentiation of numerator, which will become cos x, minus numerator, which is sin x, into differentiation of denominator, which is x square, whole thing divided by the denominator, which is x square whole square. So it will become x square cos x minus 2x sin x divided by x to the power 4. Okay. So this is what our dy by dx will be. So just note down the formula in both the forms, this form as well as this form, and go through the steps of this particular example carefully. Then we'll discuss more examples based on this.
Sir.
Yes.
Sir, I just shared you a doubt about the paper.
Okay, I'll go through that.
Sir, on WhatsApp.
This one, the word question that water being poured in the tank.
Yes, sir.
Yeah, I'll explain this question in detail. Don't worry. Okay, I'll be taking up the doubts of the test paper and discussing in detail in some time.
Sir, could we differentiate that sin x by x squared like sin x into x to the power -2?
Yes, very good. That's another thing you can do over here. You can convert it into, instead of a quotient of two functions, you can convert it into the product of two functions, and you can show that it should come out to the same as this. Okay, so how we'll do that is, see, if I treat it like this, alternate method of doing this, very good, is that I can treat sin x upon x square as x to the power -2 into sin x. Okay, and I can use the product rule. So dy by dx will become what? Differentiation of x to the power -2 into sin x, right? Plus x to the power -2 into differentiation of sin x. Okay. Now you can simplify this further and show that you will get the same as this. When you do this now, it will be equivalent to this. Okay. So if you finished writing down up to here, you can just try this yourself by this method also.
Sir, y is equal to sin x by x square in the question. So, sir, it will be x to the power -2 or x to the power 2 in the first step of derivation.
No, see, in the first step of derivation, what is the denominator? It's x square. No? Denominator is not x to the power -2.
Yes, sir.
So it's x square only. No? The function in the denominator is x square. No? So when we apply in the formula over here, capital D or gx over here will be substituted as what? X square. You following it?
Yes, okay, sir. Got it.
Whereas if I want to convert it like this, that it is something into sin x in the numerator, then to bring x square in the numerator, I have to write it as x to the power -2. Okay, so differentiation of x to the power -2 in this case is how much? -2 x to the power -3. And differentiation of sin x is cos x. So we'll get like this. -2 sin x by x cube plus cos x by x square. That you can see is the same as this, no? It is cos x by x square minus 2 sin x by x cube, which is, by the way, this only. If you simplify this, you'll get this.
So if y was equal to anything in the numerator and the denominator was sin x, so we'll get like after differentiation, we'll get sine square x as the denominator.
As the denominator, that's correct. Yes. Okay. For example, you can prove that the differentiation of cosec x is minus cosec x cot x by writing it as 1 upon sin x and then using this division rule. But 1 will become a constant. So that numerator is actually a constant function.
Yes, sir.
Yes, and so there are a lot of these like interesting kind of manipulations you can do. Okay. So another simple proof that you can show for a trigonometric formula is that you know that differentiation of tan x, if you have the function y equal to tan x, you can also express it as sin x divided by cos x. Okay, and then you can find dy by dx using the quotient rule. given that you know that differentiation of sin x is cos x and differentiation of cos x is equal to minus sin x. So using these two values, now you can apply the quotient rule here, apply these formulae over here in the quotient rule, and then prove that differentiation of tan x is sec square x, which you know as a fact. So try out this example. Okay, show that it should be coming out as sec square x, and also do one more question. Now, this is the type of question which was we were asking earlier. So here also we have no option but to use quotient rule, because we cannot simplify this. Had x square plus 1 been in the numerator and x in the denominator, then obviously we don't need to use quotient rule, but have simplified and differentiated. But here we cannot do that. We cannot simplify this, so we will have to,
So I guess like the same question that came also in the test.
Yeah, I told you that, but that question I will get it cancelled from the test domain, because I've taught you only today about how to solve it. Right?
Yeah.
Yeah, very good. So 1 plus tan square x is the same thing as sec square x.
1 plus cos square x.
No. 1 plus tan square x as an identity is equal to sec square x, no? So
Yes,
two
sir.
important identities in trigonometry that sometimes you might need in calculus are these two, that cos square x plus sin square x is equal to 1. Okay. And 1 plus tan square x is equal to sec square x. Okay. And there's one more identity, no? Anybody remembers?
Cosec square x
Cosec
minus
square
cot square x
minus cot square x equals to 1.
Cosec square x minus cot square
Cot square x equals to 1.
is equal to 1. So these are things that we'll be using a little bit in future. Also, when we do integration, you'll see these will become important. Okay.
So for the tan x question, like this tan x, the answer was sec square x, right?
Yes, the answer is x square x. So you can prove it like this, that dy by dx is denominator into differentiation of numerator, okay, minus numerator into differentiation of denominator, divided by whole square of the denominator. So you'll see that not only this, but this identity will come in useful now. So this will become cos square x plus sine square x, which will become 1 by cos square x, which will become sec square x. So this shows us that differentiation of tan x is equal to sec square x. We are proving this, but of course, making use of the fundamental formula that differentiation of sine is cos and differentiation of cos is minus sine. Okay, so this term here, it will become minus sine. This term will become cos. So that's how we are getting cos square plus sine square. Okay, so hope this is clear to all of you. Now let's come to the last question, or the second one. So dy by dx once again will become denominator, which is x square plus 1, into differentiation of numerator, which is actually 1. Okay, when you solve, minus numerator into differentiation of denominator, divided by the denominator whole square. You can see this x square plus 1 minus
2x square.
minus 2x square. Okay. This will become 1 minus x square upon x square plus 1 whole square. You can simplify it a little further by writing this as 1 minus x into 1 plus x also, but this is also all right on its own.
Sir, d by dx of x square plus 1 should be 2x square plus 1, right?
Nee, beta, 1 is a constant now. So its derivative is 0 now.
Oh, yeah, yes, sir. Sorry.
Okay. Now, final thing we learned today before we come to the doubts of the test and all is the all important chain rule. Now, chain rule is more than a property. It is actually a method of differentiation that we use to differentiate certain types of function called composite functions. Okay, so it is a method for differentiation of something called a composite function. So composite function is a type of function which in common language we say function of function, or two layers of functions, one on top of the other. That kind of thing, that kind of operation is called a composite function. So we can visualize a composite function, or we can represent it by something like this, that it is one function operated on another function. So it is literally f of g of x, where this is also a function, this is also a function. So it is a function of a function. So a good example of that would be, let's say, y is equal to e raised power sine x. So you can see that in this operation, what we have done is on x, we have first operated sine. So we got sine x. Okay, and then we've operated the exponential function on that. So we've got, but exponential of what? Of sine x. So we got e raised power sine x. So what we've done is, this is our operator g. So on applying that on x, we get gx, which is this. And then we've operated f, but we've operated f on what? We've operated on g and not directly on x. So this is our this. So this is an example of something where e raised power sine x, basically we are saying, is f of gx, where the representation of f and g is in the diagram below. Okay, so anything where you suspect that from a value of x to get the value of y, you have to do two operations. So for example, in this function, y is equal to e raised power sine x. If I ask you that find y when x is equal to, let's say, pi by 6. So to get the value of y, I have to do two operations. First I have to find out that, okay, sine pi by 6 is how much? It is equal to half. So therefore y is equal to how much? E raised power sine x. So that will become e raised power sine pi by 2. So that will become pi by 6. So that will become e raised power half. That means it is square root of e. So I'm doing two operations. First I'm calculating sine pi by 6, and then I'm putting e to the power of that, which is half. So finally the value of y is coming as root e. So whenever we have a function where you have to do two operations, one on top of the other or one on the other, that kind of function is called a composite function. So first note down this definition of composite function and understand this example of it. Then we will see that once you're clear about how to recognize that a function is composite or not, then you will see that chain rule is a very logical and simple method of differentiating such a function.
So
yes.
So can you explain this again? Y equals to e sin x.
हाँ, so suppose मैंने function को ऐसा लिखा ना, y is equal to e raised power sin x. So मैं x के value से y के value तक कैसे पहुंचूंगा? पहले मैं x पे sin operate करूंगा.
Yes sir.
और फिर जो भी value आता है sin x, मैं I will use that as the power of e.
Yes sir.
Got it now?
That I got. So I'm saying where. So this one, the below one, y equals to e sin x, where you solve.
So now I'm asking, what is the value of y when x is equal to pi by 6? So how I'll solve for this now? In that above diagram only, first I'll substitute x as pi by 6. So I'll come to the middle part where sin x ka value kitna aa jayega? Half.
Okay.
Then what I have to do? I have to put e to the power of that quantity. Na? So e to the power of sin x will become e to the power half. Na? So to get from x to y, I have to do two operations. I have to do two calculations. First I have to calculate sin pi by 6, which is coming out to be half. Then I have to raise e to the power of that. So that's coming out to be root e. So that's how I'm getting the value of y is how much? Square root of e when the value of x is pi by 6.
Okay, sir. Yes, sir.
So what if they don't provide us any value of x?
नहीं, value तो मैंने example के लिए दिया बेटा. मतलब obviously the function will be a general function. No, y will be a function of x. You understanding? No? So the function given will be like, for example, this one, that e raised power sin x. But on looking at the function, how you recognize whether it's a simple function or a composite function. So for it to be a composite function, you have to do two operations, one on top of the other. You can see ना, e raised power sin x में दो operations है.
Yes.
Exponential भी है और sin भी है ना?
Yes.
So the moment you see that there are two operations contained in a given function, that means we know it's which type of function, composite function. So far we are only seeing the definition of composite function. This is not chain rule. Okay, we will come to chain rule next. First thing you have to understand that what is a composite function.
Sir.
Yes.
Sir, so in this case, first we'll solve the part of sin x as cos x and then e raised to sin x.
For the differentiation?
Yes, sir.
Yeah, we'll do something like that. But before that, we'll understand that there's something called chain rule. So how to apply that chain rule? From that, we'll understand why it will come that way. That it will be differentiation of sin x into e raised power sin x.
Sir, sir,
Yeah, tell me.
so what I've written on the second last line, sine pi by 6 equals to
Half, no, beta. 1/2.
1
Oh,
by
it's looking, yeah, sorry, it's looking that 1 and by sine I've got 1/2.
Thank you,
That's
sir.
how we are getting this root x, no? Root e, sorry. Okay, so this is clear so far?
Yes, sir.
Okay, now we come to the most important thing, that how we can differentiate by composite function by using chain rule. Okay.
So can you show the last line for a second?
Yeah.
So on the right hand side.
Yeah, this only, no? Root e. Yeah.
Yes, sir. Just a second.
ठीक है, clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Thank you.
Okay. So differentiation by chain rule. So for a given composite function, to apply chain rule, we have to basically execute 3 steps. Okay, step 1 is called a substitution step. Okay. So in this step, what we do is we substitute z as some new variable as g of x, the inside function. So this variable that we have substituted, you can even think of this like a dummy variable, because this is a extra variable that we have substituted to solve the question. Okay. So the moment we substitute z as gx, then what happens to y? It becomes f of z. Okay. So let's understand this first step and each of the steps with an example side by side. Okay. So in that example I had earlier, y is equal to e raised power sine x. So what we had done on x, we had operated sine first. So we got sine x. And then we had operated exponential. So we got e raised power sine x. Okay. So what was the inside function? It was this one. This was gx. Right.
Yes,
And
sir.
what was the outside function? It was the exponential function. F was exponential. So here what we should do when we are differentiating, the step 1, substitution, we should substitute z as what? Sine x. So that is our gx. Okay. So our y will become what? It will become e raised power z.
E raised to sine.
So this is what we are getting by the first step, which is the substitution step. Okay. Now the second step immediately after this is in fact what we call the chain rule step, because we apply the method of chain rule here, that differentiation of y with respect to x will be how much. Now you see the above 2 statements which I've written here, this and this, isme y to x pe depend hi nahi karta. Y is a function of z and z is a function of x. So that means I cannot directly find dy by dx. You're understanding my point? Because now I've defined y in terms of z. So I can define dy by dz instead. Okay. And z is a function of x. So if I differentiate z with respect to x, I'll get dz by dx. And when I multiply these 2 terms, that should be equal to what? Dy by dx. You understanding now? Change in y upon change in z into change in z upon change in x. That should give me what? Rate of change of y with respect to x. So it's a logical step. So when we substitute this here, this step will become what? It will become differentiation of fz with respect to z. So I can write that as f prime of z. Okay. Into differentiation of z with respect to x. So that will become what? G prime of x. Okay. So dy by dx is like this so far. So we are almost done with the differentiation. The only problem is that I have expressed dy by dx in terms of the dummy variable. So the dummy variable has to be removed because I have introduced that. So the final step, which most people don't even think of as a separate step, it's part of step 2 only, but I will write it as a third step just to make it more systematic. And we call that the re-substitution step. That we re-substitute the value of z as gx, what we have done above, in the derivative, like in this. So what happens is dy by dx, in place of z, I will write what? Gx. Right. So I'll express this as f prime of gx.
Sir,
into g prime x. Yeah, and this becomes my final answer. Yes, tell me, beta.
sir, how do you read that dummy variable?
How do we?
Sir, like how do you pronounce that? What do we read
Dummy.
it as?
Du double my, dummy variable. Okay.
No, I'm just asking that there is no name for that.
Z है वो.
Okay.
Z भी उसका नाम Z रख सकते हैं, U रख सकते हैं, T रख सकते हैं, any symbol, है ना?
It's like a dummy variable.
It's an extra variable that I have introduced, so I'll remove it in the end. So I'm using the symbol Z for the dummy variable. You can use the symbol U, T, S, whatever, any symbol you can use, so long as you finally remove that variable by resubstituting. You understanding now?
Yes. Yes.
Okay,
sir.
now before you note this down, let's execute these steps for this particular example so that we understand it. So step 1, we have done substitution. All of you understood?
Yes,
Y
sir.
was e raised power sin x. तो मैंने sin x को dummy variable बना दिया z. So y क्या बन गया? E raised power z. Okay. Now the second step, chain rule. So here dy by dx will become dy by dz into dz by dx. So dy by dz is basically what? It is differentiation of this function e raised power z. So e raised power z's differentiation, you know, is what? It's e raised power z only. Whereas dz by dx, it is differentiation of which function? Sin x. So differentiation of sin x, you know, is cos x. Now, so we have come up to this step. Step 2 is done now. Now final step. So we have got the answer, but only thing is answer is in terms of z. And z is which type of variable? It's a dummy variable. So I have to remove that. So step 3, I have to eliminate z by using the resubstitution. So I'll resubstitute z as what? Sin x. So dy by dx is becoming what? It is becoming e raised power sin x into cos x. Okay. So this is my differentiation of y with respect to x. So this simple 3-step process, now if you apply every time you come across a composite function, you will see that chain rule will not be something difficult at all. It will be just as easy as any other differentiation. Okay. Whereas like if you try to do, if you try to jump to step number 3, like given some function, try to directly calculate f prime of gx into g prime x, you might make a mistake or you might get something wrong, especially in the beginning. So what I would advise you is that when you're doing the first assignment of chain rule and the questions from the module and all, for the first few questions, at least for the first 20 or so questions, apply all these steps and write it systematically. Then when you start getting comfortable with it, then you can start skipping few steps and eventually you will come to a stage where you can look at a function and directly apply this step, the final step. Okay, but initially make sure you're understanding what is your dummy variable, then you are applying the chain rule using the dummy variable, and then finally you're resubstituting to get the answer of dy by dx. Okay, people, so hope this is clear. Note down both the steps on the left hand side and the application of the steps in this particular question on the right hand side. Then we'll do a practice question and you'll see it will become very easy for you to solve.
So,
yes.
So, sir, we can always exponential is as a dummy thing, and then that we calculate, and then finally we can just replace it.
Nee, what you're saying, we should put the dummy variable as what?
So the exponential, the power.
Sin x को dummy variable रखेंगे ना, because यहाँ पे it is e raised power sin x. You understanding ना?
Yeah.
Now, what is the first operation we have done on x? Sin x, no? Then the second operation is e raised power. So what we should substitute as z? Sin x, no?
Yeah. Okay. Understand.
Okay.
Sir, done.
Okay, so understood this
So 1
example.
minute.
So
Yeah.
1 minute.
Yeah. Okay, so those who have finished writing this down, just try out this next question. Y is equal to square root of x square plus 1. Now we want to find dy by dx.
Sir,
Yes.
sir, step 2, can you explain me again?
Step 2 is just a logical step that I want to find rate of change of y with respect to x. So it is change in y upon change in x, dy by dx, right? So that I can express as dy by dz into dz by dx.
Yes, sir.
It is like, if you know the rate at which, we know how many kilometers per liter of petrol your car gives in mileage, and we know the price of petrol in number of rupees per liter. So then we can use the two rates to calculate how many rupees per kilometer or how many kilometers per rupee. Like that, if we know that how y is changing with respect to z, we know the rate of change of y with respect to z, and we know the rate of change of z with respect to x. Then by multiplying the two, we will get the rate of change of y with respect to x.
Okay, sir.
Sir,
Yes.
sir, so in the sum that was given in the paper, that root of tan root x.
We have to use chain rule only.
So, sir, first we'll have to solve the power half, then we'll have to solve the tan function, and then the function of root x, no?
Yes. So you will substitute root x as like z. Okay, so let's see the steps in this question. One person has got the answer correct so far, and that is Harsh. Okay, so anyhow, let's see. So we have y is equal to, what was it, square root of x square plus 1. So logically, you can see it's a composite function, because I have to first operate the quadratic function on x. No? First step is I have to operate this quadratic function whole square plus 1 to get x square plus 1. And then on that, I have to operate the square root function to get y, which is square root of x square plus 1. So this is my gx. Okay. And then this is my f of gx. So the first step, the substitution step, I'll substitute x square plus 1 as z, which is my dummy variable. So now y will become expressed as what? Square root of z, or you can also write it as z to the power half. So next step, the chain rule. So dy by dx, rate of change of y with respect to x. is rate of change of y with respect to z multiplied by rate of change of z with respect to x. Like this. Okay. So just plug in the values. So this is basically what? The root z function. Y is equal to root z, you can see. So we'll get 1 by 2 root z. Okay. Rule step, we've got the value of differentiation, but only thing is we have to eliminate z because it's a dummy variable. So step 3, which is our chain rule step, which is our re-substitution step. So just substitute z as x square plus 1. So this is our differentiation. This is the answer.
Sir, how did we get 1 by 2 root z?
That is again coming from the formula that differentiation of root z, okay, is differentiation of z to the power half, correct? So that is 1 by 2 into z to the power half minus 1.
Yes,
I'm just
sir.
changing the name of the variable, but rest the formula is the same. No?
Yes, sir. Understood.
So it's basically just like we had seen differentiation of x to the power half with respect to x, like that differentiation of z to the power half with respect to z.
Yes, sir.
Okay. So let's just complete this chain rule with another example because it's a little bit complicated. So I want you to get used to this. Okay. So y is equal to sine square x. What about dy by dx? Okay. So actually, you will see the first step is the critical step, that you have to decide what you take as z. Once is what you should substitute the demi variable as. So here, tell me what should be z?
So sin x.
Yes, very good. If I substitute z as sin x, then y is very simple, right? It is z square. So step 1, z is equal to sin x. So therefore y is equal to z square. This is our substitution for the dummy variable. Okay. Then our step 2 is very simple. Now I'm going to go a little faster so you can see directly dy by dz kya hoga mera? Y z square hai. So dy by dz will be 2z, correct?
Yes, sir.
Yes, sir.
And what about dz by dx? It is a differentiation of sin x. So that will be what?
Cos x.
Cos x.
Sir, it would be 2 sin x cos x, no?
Yes. So finally, my re-substitution ke baad, my step will become
Thank you, sir.
Thank you, sir.
Bye, sir.
Yes, sir.
Bye, sir. Bye, sir.
Bye, sir.
Yes, sir.
Thank you, sir. Bye, sir.